The National Airspace System is one of the most reliable systems ever built. Every day, thousands of aircraft move through complex airspace with extraordinary precision. Delays happen, weather happens, congestion happens. Yet catastrophic failures are rare. But here's the uncomfortable truth. The system's greatest strength is also its most predictable vulnerability. Air traffic control depends on the human brain. Controllers operate in what we call a high reliability system, a system designed to function nearly error-free in inherently hazardous conditions. To do that, the brain relies on two modes of thinking. System 1, fast, intuitive, pattern-based. This is what keeps traffic moving. And System 2, slower, deliberate, analytical. This is what verifies safety when things feel uncertain. In high-tempo operations, System 1 dominates, and most of the time, that works. But when expectation replaces observation, when pattern recognition replaces verification, error begins to take shape. Not because someone is careless, but because they are human. Let's clarify something critical. Cognitive bias is not incompetence. It is not negligence. It is not lack of skill. Bias is a normal cognitive adaptation. The human brain cannot process every piece of information in real time, so it relies on shortcuts, heuristics, to manage overwhelming data loads. Perception is shaped by 1. Prior knowledge, 2. Experience, and 3. Anticipated outcomes. That's efficient. In air traffic control, 4 biases commonly emerge. Expectation bias, perceiving based on routine rather than current data. Confirmation bias, noticing information that supports what we already believe. Plan continuation bias, sticking to a plan even as conditions change. Automaticity, executing routine responses with minimal conscious review. These are not defects. They are predictable features of human cognition in high information environments. And in aviation safety, what is predictable must be engineered around. In air traffic control, the primary procedural defense against miscommunication is the readback/hearback loop. It is mandated in the FAA Order 7110.65. The process is simple in theory. The controller issues a clearance. The pilot reads it back. The controller verifies the readback. This loop is designed to catch errors before they propagate. It is supposed to be the barrier. But expectation bias can bypass it. When a controller expects to hear a specific altitude, runway, or instruction, the brain may unconsciously fill in the expected words, even if something different was actually said. This is known as the autofill effect. The mind completes the pattern it anticipated. Now consider the pilot's perspective. If the controller does not correct the readback, the pilot interprets that silence as confirmation. This creates what we call silent confirmation. No one intended to accept an error, but both parties walk away believing the loop worked. Psychology has now penetrated procedure, and the system vulnerability is no longer abstract. It is operational. Bias alone does not cause accidents. Bias becomes dangerous when independent verification is degraded. Environmental conditions amplify cognitive vulnerability. Low visibility and dense fog eliminate visual crosschecks. Night operations reduce depth perception and spatial cues. Frequency congestion divides attention and compresses decision time. Complex airport geometry increases cognitive load. Compressed operational tempo narrows attention. Under these conditions, operators rely even more heavily on expectation and pattern recognition. System 1 dominates. And when independent confirmation tools, visual, technological, or procedural, are limited, the brain's internal model can quietly drift away from physical reality. That is when margins collapse. Let's move from theory to reality. On February 4th, 2023, at the Austin Bergstrom International Airport, a dense, freezing fog reduced visibility to roughly a quarter mile. Low IFR conditions meant there was no reliable visual confirmation. Critically, the tower did not have ASDEX surface detection technology. That meant the controller had no independent electronic verification of aircraft position. He was operating almost entirely on verbal reports and his own internal expectations. A FedEx Boeing 767 was cleared to land on runway 18 left. A Southwest 737 reported ready for departure on the same runway. In the controller's mental model, Southwest would be airborne before FedEx reached the threshold. That assumption felt routine, but physical reality was different. Southwest performed an uncommunicated cold weather engine run-up. It took them 57 seconds just to taxi onto the runway. Meanwhile, the FedEx aircraft was descending through the fog. Then came the confirmation trap. FedEx queried the controller to confirm landing clearance. Clouded by expectation bias, the controller reaffirmed the clearance, believing Southwest was already rolling. In reality, the aircraft were separated by as little as 150 feet. Seconds mattered, and the system nearly collapsed. The NTSB later identified expectation bias as a contributing factor. This was not incompetence. It was a lethal drift between a mental model and physical reality, under degraded verification conditions. This case is the anchor, because it shows how predictable cognitive behavior can penetrate procedure when safeguards are missing. Austin was not unique. In January 2023 at JFK, an American Airlines 777 crossed an active runway in front of a departing Delta 737. The difference? JFK had ASDEX. Visual and oral alerts interrupted the controller's expectation, and the collision was prevented. In April 2024 at Reagan National, a Southwest 737 and a JetBlue Embraer 190 stopped within 300 to 400 feet of each other. The event involved an infrequently used runway configuration. Non-standard geometry triggered routine assumptions. Again, expectation met complexity, and the margins compressed. This pattern is reinforced by research. In a NASA review of 37 accidents, 75% of tactical decision errors were linked to continuation of the original plan. Plan continuation, bias, attentional narrowing, reluctance to disrupt flow. This is not random. It is recurrent. It is systemic. And that is the most important realization. We are not looking at isolated human mistakes. We are looking at predictable cognitive dynamics interacting with operational complexity. Here's the critical shift. We cannot train away human nature. Cognitive bias is not a temporary flaw that disappears with more experience. It is the byproduct of how the human brain manages complexity. U.S. safety literature rejects individual blame as an explanation for systemic outcomes. In dynamic, high-tempo environments, error-free human performance is impossible. So the objective is not perfection. The objective is design. Not eliminating bias, but building systems that assume bias will occur. That is the foundation of true defense in depth. Safety does not come from better humans. It comes from better system architecture. So what does that look like in practice? It means injecting independent, disconfirming evidence into the control loop. Technology becomes the counterweight to cognition. ASDEX and ASSC provide surface surveillance and visual or oral alerts when aircraft conflict. Runway status lights operate autonomously. Embedded red lights that signal runway occupancy directly to pilots, independent of verbal clearance. Surface awareness initiatives extend situational awareness to towers that lack legacy installations. And beyond technology, safety management systems identify cognitive bias as a systemic hazard, tracking trends before accidents occur. Team resource management fosters a culture where assumptions are actively questioned and peers are empowered to challenge unsafe clearances. The principle is simple. If the human brain tends to confirm expectations, the system must aggressively introduce evidence that challenges them. Verification must be independent, not assumed. So, We end where we began. Bias is predictable. Mental models drift. Aviation does not survive because humans are perfect. It survives because verification interrupts error before it becomes tragedy. The goal is not eliminating human bias. The goal is eliminating the systemic gaps that allow bias to pass through unchecked. In aviation, safety is not about certainty. It is about verification. This is Aerospace Universe, your place to understand aerospace complexity and strengthen the safety of our skies.